Hello, I hope you're all well wherever you may be today. Thank you very much for attending my conference. My name is Sonja Bemel. I am CEO of Watershed Monitoring, and I have the pleasure to present to you today 10 years of applied research on planning, managing, and optimizing river and lake monitoring programs, participative approaches, data management tools, and intelligent decision support systems. So as you all know, we have lots of challenges in integrated watershed management, and some of these challenges are to get a reliable assessment of water quality through water quality monitoring programs, and also to induce stakeholder involvement to make sure that everyone understands the stakes and everyone is happy to take joint decisions and actions to protect the resource. So in order to get everyone there, we need reliable data because we cannot take decisions without data which also generates the knowledge which we actually really need to have to be able to take decisions. So first of all, in order to generate that data, it is really important to induce stakeholders to participate in order to identify the knowledge needs and the preoccupations which everyone might have in order to then plan data acquisition for data which is the raw material which needs to have a very solid foundation in order to be able to produce the information which we then need to manage correctly through structured data, semi-structured data, and non-structured data, and of course metadata, which will then generate the next step, which is the knowledge and the information which we can eventually also share through a smart grid, which will take us to decisions and actions. So this is actually the elements of information which I would like to communicate to you today on a specific case study in Quebec in Canada on the Lake St. Charles River watershed. But before we get there, we also need to think for whom we actually produce the data, for when we produce the data, and under which form we produce the data. So that is all in essential reflections which you need to have when you attack yourself on a specific watershed in order to induce everyone to act upon the data in order to pass to the action to protect the resource. And so I would like to introduce you today to the St. Charles River watershed, which is a small watershed of only 550 square kilometers on the St. Lawrence River in Canada. And part of this watershed, actually 348 square kilometers of it, are also the watershed of the main water intake for the 300,000 people of the population of the city of Quebec, a watershed which is very heterogeneous, albeit very small, but with lots of different municipalities and a lot of pressure on the water resources. So we actually decided to go from the first water quality monitoring program, which was planned in 2010 based on a participative approach, which implied several stakeholders, but which was not all that inclusive yet. So we actually decided to renew that water quality program in 2015-16 after the first cycle of 6 years. And we developed participative approach, which was which took several steps. First of all, actually, we decided to hold stakeholder analysis in order to be able to really find out who needs to be involved and who needs to be contacted in order to understand what these people's preoccupations are on water quality, what are their knowledge on water quality, and what are their knowledge needs. So for the stakeholder analysis, we set the survey objectives, we identified stakeholders and circumscribed the area, which was quite important because we actually eventually decided not only to contact stakeholders from the watershed, but actually also stakeholders which use the waters of the watershed, but which do not actually live there. So for instance, most of the population of the city of Quebec uses the water, but is actually not even living in the watershed, which everybody else then needs to protect. So we of course prepared the survey, tested the survey with several people, And we also decided to develop a public participation geographical information system in order to help people pinpoint all the areas of preoccupations and of problems related to the water quality. And then, of course, we went to the next step, which was the communication of the survey to social media, phone calls, mailing lists, local papers, and websites. At the next step, we actually did the analysis of the survey. We identified the level of concerns on water quality and quantity. We inferred also preferred communication channels. That is, what is the type of information stakeholders would like to have and under which form and when and for whom they would like it to be produced. We also went to a next step to a more in-depth discussion. So we held stakeholder workshops where we actually tried to get the stakeholders, we presented to them the preoccupations of the populations and all the other stakeholders which couldn't be present. And we challenged them with these preoccupations and discussed them. And finally, we within the information from the stakeholder workshops and the surveys and the PPPGAS, we were able to come up with several monitoring objectives. And we submitted these monitoring objectives to the watershed organization of the case studies in order to prioritize the optimization objects of their respective water quality monitoring programs. And we actually went also to develop new monitoring objectives. So for instance, for this watershed, we actually involved more than 250 people during this whole process for this small watershed. So we actually were able to produce monitoring objectives for the current water quality monitoring programs and several objectives which were identified through the participative approach, and we were able to identify the preferred communication channels and also many elements on preoccupations on water quality throughout the watershed which were communicated to us. So based on all this information, we then went to through the next step, which was to propose an optimization of the water quality monitoring programs of these watershed organizations. In order to be able to get to the optimization or even to the production of water quality monitoring programs, we need to go through a very good planning process. So the first step was to be certain about the knowledge needs. The next step was actually to really think about what are the elements which need to be which we need to be taken into consideration to produce the good water quality data after having identified the monitoring objectives. So that is all the elements on having sampling sites, water quality parameters, sampling frequencies and recurrence, to think about logistics, technical means, financial and human resources, information channels and use. So what we developed based on these considerations during these studies and the process, we actually developed two elements which were fundamental to get there. The first which we developed is a water quality database, Enki, which I'm not going to too much into detail today. I'm just going to show you a couple of elements. But we actually also developed an intelligent decision support system in order to plan, manage, and optimize water quality monitoring programs. So these actually is the conceptual model of the intelligent decision support system which we developed. And actually the design here is to show that we need to imply a lot of people in order to plan this. We need the stakeholders, the biologists, the ecologists, the limnologists, the hydrologists. We need to have geomatics on board, the project managers, the accountants of the monitoring programs. We need to have some of business intelligence integrated. We need to talk to the technicians, the laboratories, the quality control managers, the people who produce and sell those probes, and we need to have the communications specialists and data managers in order to go through all the elements which are really important, is to delimit the area of your influence, define monitoring objectives, classify water bodies, establish communication channels within and without the watersheds, establish sampling frequency, sampling site network, water quality parameters, and so on. So this is the next step we went through, and this was actually essential that all these elements were connected to a database. As you know, water quality is a very precious element, but water-related data is too. And actually one of the main problems and challenges which we actually met in both of those case studies and in many others since then is, first of all, water quality related data is not well managed. It is managed through all kinds of very interesting tools, but which are not destined to manage data. They're destined to analyze it, to temporarily store it, to view it, but not to manage it with the appropriate metadata. So we developed in the past 10 years a database which we actually called Enki, which helps integrate all the data and metadata from all the water quality monitoring campaigns, going from the setting of the water quality monitoring objectives all the way to the final data and the metadata of the information which you can take on the fields, the photos, the films, the videos, the final data which was produced and to whom it was destined. So we developed that as well for the source waters with all the hydrological data integrated too. We developed it for the source water risk analysis because if you want to be eventually able to manage your data well, you need to connect your source data with the geographical data and what is going on in your watershed in order to establish the relationships and eventually connect that data to your different models. And if your watershed is destined for drinking water, it also needs to be connected to the water in the distribution system, and you need to have reciprocal communication between your citizens and your watershed managers. So actually, this is exactly what we did for the case study of Lake St. Charles watershed. And one element which is really a story of success is that these 10 years of data acquisition and data management through a well-structured database, information which was then put into knowledge, into information, into knowledge, and was then pushed into bringing action abroad for the specific watershed. We have had many successes in a precise action plan, and the data, since it is well stored, it can be used for additional studies. So the Lake St. Charles watershed is maybe the most studied watershed in Canada. And this data is always used and reused and re-injected in further studies and modeling in university studies. And all the new acquired data is also being stored back into the data. What is also really essential part of the success story of this water quality monitoring program is the fact that the stakeholders were involved from the beginning in the knowledge acquisition process. That is, that we really took into consideration whatever they needed to know, that what they wanted to know, and that is exactly the type of data which we produced. And the water quality monitoring program was totally defined for every single step of it through those knowledge needs, with the implication of all the different people in order to plan, optimize, and manage this water quality monitoring program. What is also important in conclusion is that we really need to be aware that when we work on the watershed, that we need to take into considerations local homogeneous areas, but we also need to take into consideration that the aquifers are not always connected to those surface watershed areas, and that the human catchment area is also a crucial element to be taken into account, because you cannot push some people to protect a watershed when the people from outside the watershed are actually those which use that water or even come in on as vacationists and are not aware of the challenges of the watershed and the needs to protect it. So in conclusion, data acquisition processes must undergo a certain standardization and must be made transparent and transferable. Objectives for data acquisition must be clearly defined. Decisions in the data acquisition process must be documented. Information on the data acquisition process, the data and the metadata must be stored adequately, and stakeholders must be involved in these steps. Stakeholder implication must also be documented as to know who influenced the planning of the data acquisition projects and what the objectives were in order to be able to reiterate this process every 5 to 6 years. So I would like to thank you very much, and I would be very happy to receive your emails if you have any additional questions and if you would like to learn more about the success story of the St. Charles River watershed in Quebec. Thank you very much.